Hi, welcome back. In this video, we are going to be looking at using the central limit theorem to solve a problem following the 6-step process. The average annual precipitation for a large Midwest city is 30.85 inches with a standard deviation of 3.6 inches. Assume the variable is normally distributed. A sample of 8 years is selected. Find the sample mean that will separate the lower 95% of mean precipitation from the upper 5% of mean precipitation. So I first need to start by defining my random variable. So they're telling me the average annual precipitation. So my random variable X, my individual things that I will be measuring, will be annual precipitation for a large Midwest city. And I'm measuring that in inches. So we're looking at our variable. This is what you would actually be measuring. If you were going out and collecting data, the data you would be collecting would be X's. I'm then going to be looking at samples of 8 of those years. So I'm going to pull from my problem what the mean and the standard deviation of my population of X's are. And they tell me that the mean is 30.85. and the standard deviation is 3.6. This is all in inches, so my units all match. And then I'm taking a sample of 8 years, and I'm going to look at the average for that. So now that I have interpreted and defined my problem, I'm going to move on to check. So to check, is my population normal? Yes. My population is approximately normal. So the fact that 8 is less than 30, which is not okay, the population is normal. So my variable X bar, we can assume is approximately normal. We are all good, and we can assume normality. So now I need to find my parameters. So to calculate my parameters, I need the mean of my sampling distribution, which should be equal to the mean of my population, which is 30.85, and the standard deviation of my sampling distribution, which should be the standard deviation of my population divided by the square root of n. So that is 3.6 divided by the square root of 8. Going to my calculator, gives me 1.27 as my standard deviation. So now that I have my new parameters, I can go ahead and draw the picture. So this is a distribution of X bars. They're approximately normal with a mean of 30.85 and a standard deviation of 1.27. So there is my picture. 30.85 is in the middle. And now I'm looking for the sample mean. So I'm looking for an X bar value that will separate the lower 95%. So here's my X bar that I'm interested in. I'm going to call it X bar star. And the lower 95% from the upper 5%. So in this case, I am going from an area to an X value, which means I'm going to need to use inverse norm. So I am looking the probability that X bar is less than X bar star is equal to 0.95. So this means I'm going to use inverse norm. So X bar star is equal to inverse norm of the area to the left, which is 0.95, the mean, 30.85, and the standard deviation, which is 1.27. So 0.95, 30.85, 1.27 gives me a value of 32.94. So now that I'm done with my calculations, I need to translate. So the mean annual precipitation for a sample of 8 years, that separates the lower 95% is about 32.94 inches. And there you have it.